Recording in progress.
Okay, good evening.
Good evening, Miss.
Good evening,
Good.
all of you. So I am about 15 minutes late because I had to do the grade 6 assessment today, right? දන්නවනේ තේපොල්. ඒගොල්ලන්ට assessment එක දීලා discuss කරන්න යනවා assessment එක ලියන්නට වඩා වෙලාවක්. ඇයි මම කියන answer එක මාපහු ආනවා වෙන විදිහකින් මේක හරිද කියලා ඉතින් ටිකක් වෙලා ගියා. Sorry for that, right? හරි අපි ඒ ටික ඉවරලා after 9 කරමුනේ. පරක්කු වෙලා පටන් අරන් ඊට පස්සේ වැඩිපුර කරන්න කතා කරනවා නේද? හරි, okay. Please turn on the videos. So last time we discussed about the Lewis structures. නේද? ඔන්න we know how to draw the Lewis dot cross diagram, dot diagram and also the Lewis structure. ඒ ටිකනේ අපි කතා කරලා ඉවර කළේ. Did you practice? So videos on කරන්න හැමෝම. You practice. දැන් හොඳටම පුළුවන් නේ? Any molecule out of the ones that you had learned, you are asked to draw the structure. You can manage, right? පුළුවන්ද? පුළුවන් නේ? හරි. පුළුවන් වෙන්න ඕනේ. Then once we consider those structures, then if we take, I will consider ammonia molecule, right? Ammonia. So if I draw the Lewis structure, you know, nitrogen has 5 electrons. Out of the 5, it shares 3 electrons with hydrogen, right? Shares 3 electrons with hydrogen. Right, I will draw the dot cross diagram. Then I can show the electrons. Then nitrogen has a lone pair as well. And hydrogen, each hydrogen has 1 electron. Now here you can see, in the case of nitrogen, it has completed the 8 electrons. 2, 4, 6, 8. Nitrogen has completed the 8 electrons because we know that these atoms try to obtain the configuration of the noble gases 2, 2, 8 and 2, 8, 8. And they are trying to reach this level. Okay, Harry. Then in the case of hydrogen, each hydrogen atom has completed 2 electrons. Then if I consider CH4 gathot, methane or the water molecule, whatever. Examples keep since you have drawn this. In the case of CH4, the carbon shares its 4 electrons, 4 valence electrons with 4 hydrogen atoms. Then for carbon, once again, 8 electrons are completed. 2, 4, 6, 8. And in the case of hydrogen, once again, 2 electrons are completed, right? So in most of the cases, these 8 electrons are completed, right? We call this as the electron octet. Electron octet. Octa is for 8, no? Octa is for 8. Right? Octa is for 8. So electron octet is completed for most of the molecules. Atoms, right? Now H2O gathot. Oxygen has 2 lone pairs. 2, 4, 6, 8. 8 electrons are completed for oxygen. But there are certain exceptions in which this electron octet is not completed or it has been exceeded. Hydrogen is a special case now because hydrogen can obtain the configuration of helium. Stable. Helium. So most of the others, they have to complete 8 electrons in the outermost energy level. table most of them have completed these 8 electrons, right? The central atom has completed 8 electrons. Hari. In all the molecules given above, just below the table you can write, in all the molecules given above, the central atom in all the molecules, ඒක දීලා තියෙනවලු ටියුට් එකේ. දීලා තියෙනවද ටියුට් එකේ? එහෙනම් අපි යමු එකට. Just after the table. In all the molecules discussed above, the central atom as well as the peripheral atoms. The central atom as well as the peripheral atoms have acquired noble gas configuration, right? So you can write the noble gas configurations here, 28288, helium, neon, argon. That means except in hydrogen, a set of 8 electrons is completed in the valence shell of atoms after the formation of the bonds, right? Those are known as compounds in which the octet of electrons is completed, right? Electron octet is completed. There are exceptions as well. We are going to mention about these exceptions. One is aluminium chloride, AlCl3. AlCl3, aluminium chloride. What is the valency of aluminium? How many electrons are there in the valence shell of aluminium?
3.
3. 3 electrons are there. Now I will indicate the 3 electrons of aluminium like this. Right? So aluminium has shared electrons with 3 chlorine atoms only. පොඩ්ඩක් මට ඉඩ මදි වෙනවානේ. ඇලුමිනියම් ක්ලෝරයිඩ් අඳින්න. ටිකක් පහලට කරලා ගත්තොත් aluminium, there are 3 electrons, right? Then it has shared electrons with 3 chlorine atoms. 3 chlorine atoms. Each chlorine has how many valence electrons? Each chlorine atom has, oh, අහනකොටම කියන්න ඕනේ. Yes, Dinuli, Pavani, Manusha, Banuja, Hiruja, Roshali, Akitya, Sasen. Yeah. Able to turn on the video, please turn them on. කියක් තියෙනවද? දැන් කෑ ගහලා කියන්න ඕනේ කියපු ගමන් chlorine that there are 7 valence electrons ne. So chlorine will share 1 electron with aluminium. Then the rest of the 6 electrons will be kept as lone pairs. හරිද? තුරු 6 දෙනාම lone pairs විදිහට තියාගන්න. Then chlorine has completed the electron octet. 2, 4, 6, 8 for each chlorine. Electron octet is completed. But what about aluminium? It has obtained only how many electrons?
6.
6 electrons. 2, 4, 6. Only 6 electrons are there for aluminium. Octet is not completed. අර කියපු දේවල් වලින් වෙනස් වෙච්ච තැනක්. It is an exception. Right? අඳින්න. Aluminium chloride තව එකක් තියෙනවා in which the electron octet has been exceeded. ඒකත් කියමු. ඒකටත් ඉඩ තියාගෙන aluminium chloride අඳින්න.
Teacher, we can't hear you.
දැන් හරිද?
Okay, teacher.
හරි. PCl5 කියන්නේ phosphorus pentachloride, right? Penta is 5. දැන් එහෙම නම් තියනවානේ. Penta 5, hexa 6, ඊළඟට hepta 7, octa 8, nanane, decane, එහෙම තියෙනවා 9, 10 ඒ විදියට. එතකොට PCl 5. Phosphorus, what is the valency? What is the valency of phosphorus? Yes, කියන්න බලන්න. කියන්න valency of phosphorus.
5.
5. It belongs to group 5 නේද? එතකොට phosphorus, it has 5 electrons in the outermost energy level. So it is going to share electrons with 5 chlorine atoms. Right? 5 chlorine atoms. So 5 chlorine and ගත්තාම ඉඩත් මදි නේද? Chlorine 5. Then each chlorine has 7 electrons. එතකොට 2, 4, 5, 7. මේ වගේ. So what happens? Chlorine gets the electron octet completed. Each chlorine atom gets the electron octet completed. But what about phosphorus? What has happened to phosphorus? How many electrons are there now? Me? 2, 4, 6, 8, 10. 10 electrons are there for phosphorus. Now, that is also an exception. It has exceeded the electron octet. Exceptional cases දෙකක් ඔයාලට කියලා දෙනවා. That's all. In most of the cases, electron octet is completed. There are certain instances in which this is changed. Why aren't those ionic compounds even when a metal and a non-metal bond together? Both phosphorus and chlorine are non-metals. Aluminium chloride. Aluminium වල තියනවා නේද පොඩි amphoteric ගතියක්. The aluminium oxide is the amphoteric oxide that you learned out of the first 20 elements. So, though it is a metal, it makes positive ions, but it tends to share electrons as well. Right? Aluminium වල අර පොඩක් මැදනේ ඉන්නේ. In between metals and non-metals, but it is a metal, but it has the ability to share electrons as well rather than making positive ions. හොඳ ප්‍රශ්නයක් නේද? metal non-metal වෙලත් ions හදන්නේ නැත්තේ ඇයි කියලා අහනවා සයුල්. හරි. Then we are moving on to the atomic lattice. What is this lattice? In Sinhala we call this as a dalisa. Dalisak කියලා කියනවා. Lattice structure. In some of the elements, the atoms are organized as a lattice, right? Such lattices in which the atoms are covalently bonded are known as atomic lattices. Atoms are covalently bonded. In between the atoms, there are covalent bonds. Some of the lattices. Then we call them as atomic lattices. We are going to talk about 2 such atomic lattices. Then api ionic lattice of sodium chloride ගැන ඉගෙන ගත්තානේ. Ionic lattice of sodium chloride. Carbon naturally occurs as 2 forms of atomic lattices. One is graphite and the other one is diamond. You have learned about these two in grade 9. මතකද? මොකද lesson එක? What was the lesson? Yes. Nanotechnology. කලානේ? They are known as the allotropic forms of carbon. In addition to graphite and diamond, there are some other forms as well. These two forms differ in the way carbon atoms form covalent bonds with one another. We'll see the difference. The melting points and boiling points of covalent compounds are very low normally, but In the case of diamond and graphite, the melting points and boiling points are high due to the atomic lattice. Then when they make a lattice, what happens? In boiling and melt, in first melt, when we are melting, we have to break these bonds, right? So since they make a strong lattice, we have to apply more energy in order to break the bonds. That is why they have got high melting points and boiling points. Okay, this in it. Graphite. So here you are shown the atomic lattice of graphite. එතන බලන්න one carbon atom මේ dots වලින් පෙන්නන්නේ the carbon atoms, right? If we consider one carbon atom, I will consider this dot. පේනවද දන්නේ? හරි. I will consider this carbon atom. හරිද? Now see, with how many carbon atoms has it made bonds? Okay. 1, then 2, then 3. It has made bonds with 3 carbon atoms only. But we know carbon, the electronic configuration is 2, 4. It has 4 electrons in the outermost energy level. Out of the 4, in graphite, it has made only 3 bonds. Neither. One electron is remaining. කෙනෙක් bonds හදන්න නැතුව හැංගිලා ඉන්නවා. එයා මොකද කරන්නේ? Now here in the case of the atomic lattice of graphite, this is made as layers, right? This is one layer, this is another layer. So that free electron, the electron which has not taken part in bonding, it is moving in between those layers. Because of the presence of this free electron, graphite has got the ability to conduct electricity. හරිද? දැන් අපි කියනවානේ carbon is a nonmetal, but graphite, an allotropic form of carbon, conducts electricity කියලා. නේද? The reason is that in between these layers, that free electron is moving. As a result, graphite has got the ability to conduct electricity. හරිද? Half of you are invisible. Please turn on the videos. I don't need to mention the names time to time. That is the case of graphite. ඊළඟට since it is made as layers, these layers can slide over one another. So graphite can act as a lubricant as well, since these layers can slide over one another. අඳින්න දෙන්නත් පුළුවන්, ඇඳලා ප්‍රශ්න අහන්නත් පුළුවන්. Then in the case of diamond, you know diamond is considered to be the hardest substance. So if I consider this carbon atom, it has made bonds with 1, 2, 3, and here this is the fourth one, right? The fourth one. එහෙම නැත්නම් මෙයා ගන්න මෙතන පැහැදිලිව පේනවා bonds ටික ඔයාලට 1, 2, 3, 4. දැක්ක නේද? So one carbon atom is bound to another 4 carbon atoms. හරිනේ. එහෙනම් all the 4 valence electrons have taken part in chemical bonding. Because of that, diamond has got a very high density. Right? It is considered to be one of the substances with the highest density. It is the hardest substance. And the reason is this: it makes an atomic lattice in which all the 4 electrons have taken part in chemical bonding. Okay, Akitya. දැක්කද වෙනස? Same atom, same element, carbon, but 2 allotropic forms. They have totally different properties because of the arrangement of the atoms in the atomic lattice. පැහැදිලි නේ? දැන් බලන්න මොකද කියලා තියෙන්නේ කියලා. Graphite consists of layers of carbon atoms formed by joining one carbon atom with 3 carbon atoms. You can underline. by single bonds. These layers are superimposed on one another. Layers are superimposed on one another. Forces holding these layers are weak. Thus, one layer can easily slide over the other. Because of this structure, graphite behaves as a lubricant. Free electron එක ගැන කියලා නෑනේ. මෙතන දාගමු sentence එකක්. Since each carbon atom
Teacher, where should we write it?
Just below graphite, this description about diamond. Only
Okay.
one sentence. Since each carbon atom has a free electron, since each carbon atom has a free electron, which moves in between the layers, which moves in between the layers, which moves in between the layers. Graphite has got the ability to conduct electricity. Graphite has got the ability to conduct electricity. Hari. And then diamond. Diamond is a three-dimensional lattice, 3D, in which every carbon atom में graphite वाला දැකලා තියෙනවා නේද? අර වැලි ගෙනාම ගෙදරට දැකලා තියෙන අර දිලිසෙන කෑලි කෑලි තියෙන වැලි ගොඩේ. Those are pieces of graphite, right? So Sri Lanka is rich in these graphite deposits, right? Graphite mines are there. කොහෙද තියෙනවා කිව්වේ? Grade 9 මතක නම්. Yes. Yan. Bogala and Kahatagaha නේද?
Teacher,
ඊළඟට අපි යන අලුත් topic එකකට polarity of bonds.
teacher,
Yes.
so can you say the last word of the statement you said before?
The sentence regarding graphite.
Yes, teacher.
Graphite has got the ability to conduct electricity.
Okay, teacher.
Hari. Then we are moving on to the polarity of bonds. Now, here you should be able to remember what you have learned in the third unit regarding the electronegativity. So, what do you mean by electronegativity?
The ability of an atom to attract electrons toward itself.
Yes, Tanuti, correct. Bond electrons and all, right? The ability of an atom to attract the bond electrons of an atom when they are chemically bound to each other. Hari. So, this polarity is associated with this electronegativity, right? Then I am going to take two examples. I will consider the hydrogen molecule, H2 molecule, and HF molecule, hydrogen fluoride, right? So here Hydrogen has made one hydrogen atom is bound to another hydrogen atom, right? So they each has only one electron. That one electron has been shared. No lone pairs. And when we consider the electronegativity, both have the similar electronegativity. එනිසා මේ දෙන්න පාඩුවේ ඉන්නවා. This is a non-polar. This is a non-polar bond. And there is no polarity. බලමුකෝ මොකද්ද polarity කියන්නේ කියලා. We'll consider HF molecule. So, two different elements, atoms of two different elements. So, what can you say about the electronegativity? Which has the highest electronegativity? Fluorine. ඇඳලා ඉවර නෑ මම. The lone pairs. හරි. දැන් කියන්න. Fluorine has the highest electronegativity. Therefore, what does fluorine do? It attracts the bond electrons towards itself. මොකද කරන්නේ bond electrons ටික යාගේ පැත්තට ඇදලා ගන්නවා. Right? පොඩ්ඩක් වෙලා නේද? I will correct it. හරි. එතකොට since fluorine has a high electronegativity, it will attract the bond electrons towards itself. එයා කැමති electrons වලට. Therefore, it attracts the bond electrons also towards itself. Since the electrons are negatively charged, since this fluorine attracts the bond electrons, fluorine gets a slight negative charge. මේ මම මෙහෙම symbol එකක් දැම්මේ. A slight charge කියන එක මේකට කියනවා delta කියලා. Delta minus. පොඩි negative charge එකක් ගත්තා කියලා පෙන්නන්න. Since the bond electrons are repelled from hydrogen, hydrogen gets a slight positive charge, delta plus. හරිද? මෙයා electrons ඇදලා ගන්න හින්දා එයාට පොඩි negative charge එකක් එනවා. From hydrogen, since the electrons are repelled, it gets a slight positive charge. දැන් මොකද වෙන්නේ? The electron distribution becomes asymmetrical. Electron distribution becomes asymmetrical. ඒ කියන්නේ now the electrons are distributed something like this. මේ පැත්තට වැඩිපුර ඇදිලා ගිහිල්ලා. Right? So here the electron distribution is symmetrical. කවුරුත් ඇදලා ගන්න දෙන්න එක ඉන්නවා. Right? So this is what we call as a polar bond, polarity of a molecule. Polar bond. හැබැයි if we consider the total HF molecule, can we see any charge there? HF molecule එකට charge එකක් තියනවද? නෑ. HF molecule does not have any charge. But this electron distribution becomes asymmetrical and they get charges internally. As a whole, the overall molecule does not have any charge. Right? This is what we call as the polarity of a chemical bond. So this polarity occurs because of the difference in the electronegativity. Right? So fluorine is more electronegative than hydrogen. Bond electrons get attracted towards fluorine. Attracted towards fluorine. Electron distribution becomes asymmetrical. But the overall molecule does not have a charge. Then තේරුණාද polarity ප්‍රවීයතාවය කියලා කියනවා. But here both atoms have similar electronegativity. එනිසා the bond electrons are not attracted towards anyone. Electron distribution is symmetrical. දැන් තේරුණා නේද? The polarity of a chemical bond. දැන් ඇඳ ගන්නකෝ. So you can decide whether of them. Here I gave only 2 examples. Once you are given any different molecule, Hari Sasen, I will explain. If you are given any different molecule, you have to decide by looking at the electronegativity. Just write it down. There is a request to describe this again. I will do it. Please take down the note first. Writing, then shall I explain once again? පහලින් පොඩි ඉඩක් තියාගන්න. හරි. And here I have taken 2 examples, H2 molecule and HF molecule, right? In the case of H2, the two atoms of elements that they have taken part are similar. Therefore, they have the same electronegativity. Hydrogen, then nama hydrogen ne. The same electronegativity is there. Therefore, this bond electron pair is not attracted towards any of the atoms. Therefore, since both atoms are similar, the electrons are nicely distributed and there is no any polarity. Polar means having negative and positive charges internally. Here, the bond is non-polar. Both atoms have similar electronegativity and electron distribution is symmetrical. But when it comes to HF, you know, out of the elements that we learn, fluorine has the highest electronegativity according to Pauling scale, right? The fluorine, the value is 4. Then oxygen, 3.5. Nitrogen and chlorine have got the values 3. So these are the 4 elements that you know with the highest electronegativity. Therefore, here this bond electron, the covalent bond is there. That bond electron pair is attracted more towards fluorine because electronegativity is the ability to attract the bond electrons towards itself when it is chemically bound with another atom of an element. Fluorine likes electrons, therefore it attracts the electrons towards itself, right? As a result, now electrons are negatively charged. No, when fluorine attracts negative charges towards itself, it gets a slight negative charge. That is what we indicate here as delta minus. Since the electrons are removed or repelled from hydrogen, hydrogen gets a slight positive charge. So internally, they get charged, right? But the overall molecule does not have any charge. ඇතුලෙන් තමයි බෙදිලා ඉන්නේ. එළියට පේන්නේ නැහැ ඒක. Right? So fluorine has got a slight negative charge, hydrogen has got a slight positive charge because of the difference in the electronegativity. The bond is polar, fluorine is more electronegative, bond electrons get attracted towards fluorine, electron distribution becomes asymmetrical, and but the overall molecule does not have a charge. So this is a polar bond, polarity. Internally, there are positive and negative charges. That is what we call as the polarity of a chemical bond. Is that clear now? Then අපි වෙන කෙනෙක් ගත්තොත් NH3 once again nitrogen becomes more electronegative than hydrogen, right? Along even H2O, we are going to discuss about the water molecule. Oxygen is more electronegative. Therefore, from which element? Fluorine attracting electrons. දැන් මෙහෙමනේ. දැන් මෙතන මම ඇන්දේ ලුයිස් ස්ට්‍රක්චර් එකනේ. දැන් ලුයිස් dot cross diagram එක ඇන්දොත් මෙතන තියෙන hydrogen has 1 electron, fluorine has 1 electron. මෙතන fluorine මන් dots වලින් පෙන්නලා තියෙන්නේ. එහෙනම් fluorine dot in blue, hydrogen as a cross. එතකොට මේක තමයි electron. From which atom කියන්නේ bond electron. මේ definition එක electronegativity, the ability to attract bond electrons towards itself when an atom is bound to another atom of an element. හරි නේද? bond electrons තමයි ඇදලා ගන්න. මේ bond pair එක තමයි අදින්නේ. Is that clear now?
Yes,
හරිද?
teacher.
Bond electron is attracted towards one atom. Okay? There is okay. Okay, Anuli. Have you all written? The මේක කොහොමද දැනගන්නේ? If you are given a molecule and asked whether it is polar or non-polar, you have to consider the two elements and think of the bond. Which one is more electronegative? If there is a difference in electronegativity, it's polar. That is how you have to decide. Okay? Right. ඊට පස්සේ We are moving on to intermolecular bonds. මෙතන මම කියවනේ තව ඉඩක් තියාගන්න කියලා. මෙන්න මේ sentence එක ලියා ගන්න. මෙන්න මෙහෙම කියන්නකෝ. When two atoms of different electronegativities, when two atoms of different electronegativities are joined by a covalent bond, the attraction made by each atom on the bond electrons is different. The attraction made on the bond electrons is different. Causing an asymmetric electron distribution.
Teacher, can you repeat the last sentence, please? Causing an
Asymmetric electron distribution. Such bonds are known as polar covalent bonds. So this polarity can be mentioned regarding covalent bonds. What about the ionic bonds? Could they please turn on the videos? The මට connection issues කියලා level තියෙනවා. ඒ අරෙන්න අනිත් අය please turn on the videos and be visible. කියලා නැති අය. Yes, in the case of ionic bonds, then in covalent bonds we can talk about this polarity. But in the case of ionic bonds, then අපි sodium chloride ගත්තොත් මේක polarity එකක් නෙමෙයි. They already have positive and negative ions. We discussed නේද? Electrostatic attractions in between oppositely charged ions is an ionic bond, right? එතකොට මේක polar නෙමෙයි. It is the ionic bond. They are already ionized, right? ඊළඟට magnesium carbonate Mg plus and carbonate radical CO3 2 minus. Positively and negatively charged ions or radicals. These are electrostatically attracted. These are ionic bonds. Polarity is for covalent bonds. Understood? එතකොට all covalent bonds polar. Yes or no? Yes or no? If I say all the all the covalent bonds are polar, do you agree?
No.
No. Not all of them. Some of them have this, some of the covalent bonds have this polarity because of the difference in the electronegativity. Understood? On ionic එකත් එක්ක පටලවා ගන්න එපා. Ionic bonds වල already there are oppositely charged ions. අපි ඉගෙන ගත්තේ ions radicals and radicals ammonium phosphate. Radicals ammonium NH4 plus phosphate PO4 3 minus. Right? මෙතන තියෙන්නේ ions and radicals oppositely charged. They are attracted due to electrostatic attraction. Ionic. හරි නේද? නොවා හොඳට හිතට ගන්න concepts. එතකොට ප්‍රශ්න අහනකොට වරදින්නේ නැහැ. Right? හරි. ඊපස්සේ මොනවද මේ intermolecular bonds. දැන් polarity is there inside the molecule. දැන් කියන්නේ intermolecular, in between the molecules. Intermolecular bonds. Now, intermolecular bonds can we talk about the water molecule. If I draw the Lewis structure of the water molecule, I told you in 3-dimensional space, water molecule is an angular molecule. I asked you not to draw it as a linear molecule. CO2 we can draw as a linear molecule, but H2O we draw like this because according to the arrangement of the electrons in 3-dimensional structure in space, it is distributed as an angular molecule, and oxygen has 2 lone pairs here. Harida. And then we can talk about the polarity of the water molecule. Who is more electronegative? There are 2 OH bonds. Right? Which is more electronegative?
Oxygen.
Oxygen is more electronegative. එතකොට මොකද කරන්නේ? Oxygen attracts this bond electron towards itself. මේකත් ඒ වගේ. Oxygen attracts the bond electron towards itself. Electron pair towards itself. එතකොට oxygen gets a slight negative charge while each hydrogen atom gets a slight positive charge. Right? එනිසා මොකද? Water is a water molecule is angular and also it is polar. There is a polarity. Right? Now there are the charges like this on the oxygen atom and the 2 hydrogen atoms. So what are those intermolecular bonds? If we consider few water molecules, one water molecule here, right? The 2 lone pairs. So this is delta plus, delta minus. Then another water molecule here. 2 lone pairs. The charges delta minus, delta plus, delta plus. Okay, if we take a certain volume of water, there are so many water molecules there. So another one, if I draw like this, if you are asked to show the intermolecular bonds in between water molecules, you need to draw at least this type of 3 molecules, right? The 2 lone pairs. And I have drawn 3 water molecules. Then this has a slight negative charge. This has a slight positive charge. එතකොට negative positive තිබ්බ ගමන් මොකද වෙන්නේ? There are attractive forces in between them. මෙතන attractive force එකක් හදාගත්ත in between hydrogen and oxygen. Hydrogen of one molecule and oxygen of another molecule. Here also the same. They make attractive forces in between the molecules. මෙන්න මේවට තමයි අපි කියන්නේ මොනවද? Intermolecular bonds කියලා. Intermolecular bond in between the molecules. දැන් ඔයගොල්ලන්ගේ තියෙන ඉස්කෝලවල inter house sports meet. in between the houses. Inter-school competitions are there in between schools. So intermolecular can in between the molecules, right? Intermolecular bond. These are actually hydrogen bonds, right? These are hydrogen bonds. These are weaker than the covalent bonds inside the molecule. මේ molecule එක ඇතුලේ තියෙන covalent bonds වලට වඩා මේවා weak. Right? Now water is a liquid at room temperature because of these intermolecular bonds. Why? In order to take this to the gaseous state, we have to break these bonds by applying energy. The intermolecular bonds break karala, we have to separate the water molecules, take them to the gaseous state. That is why water has got a high boiling point, 100 degrees Celsius. Right? Enisa tamai water exists as a liquid at room temperature. That is very advantageous. Liquid water we can't think of a life. On earth we find life because we find one reason is that water exists as a liquid at room temperature. Right? And in the first unit you have learned that water has a high specific heat capacity. Water can absorb large amount of energy without increasing its temperature that much. Water can act as a coolant, in other words, because of these intermolecular bonds. So these are very important for the characteristics of the water molecule. ඉඳලා පෙන්න ගන්නකෝ. අපි ඒ ගැන ලියලා I will show you a video as well. So shall we write down like this? The attractive forces in between molecules. The attractive forces in between molecules are known as intermolecular forces. Intermolecular forces or intermolecular bonds.
Miss, can you repeat it from the beginning?
The attractive forces in between the molecules. The attractive forces in between the molecules are known as intermolecular bonds or intermolecular forces. Then you are given the description here on the next page. These intermolecular forces are not strong as the covalent bonds. These are not strong as the covalent bonds, right? Not strong as the covalent bonds between the oxygen atoms and the hydrogen atoms in a water molecule. Some special properties possessed by water. On a bohoma popular question, right? What are the special properties possessed by water due to the presence of intermolecular forces? Being a liquid at room temperature. Why? It has a high boiling point, that is 100 degrees Celsius. Then high specific heat capacity, you know the meaning. Water can absorb large amount of heat energy without increasing its temperature that much. Simply, right? Water can act as a coolant. Specific heat capacity api define karna in grade 11 9th unit heat lesson, right? Having a higher density than that of ice, right? So ice floats on water. That one also you have learnt in grade 10 first unit as differential expansion on freezing. Again, when the water, when freezing, during freezing, the volume increases. So what a density equals mass divided by volume. So when the volume increases on freezing, the density reduces. That is why ice floats on water. Ice floats on water. Right? That is also a feature of having these intermolecular bonds. Right? As a result of having intermolecular bonds. හරිනේ ඔන්න ටික හොඳට මතක තියාගන්න. intermolecular bonds ඇඳලා පෙන්නන්න කියලා ප්‍රශ්න අහලා තියෙනවා. අඳින්න පුළුවන් වෙන්න ඕනේ. අර විදිහට molecules තුනක් ඇඳොත් හොඳයි. එතකොට you can show the intermolecular bonds nicely. Right? හැමතිස්සෙම හිතන්න මට පුළුවන් මම කොහොම හරි කරනවා. දැන් අර එදා පොඩ්ඩක් සමහර අඩු ලුයිස් structures අඳිද්දි ටිකක් අමාරු වුණා. හැබැයි දැන් මම කොහොම හරි කරනවා මට පුළුවන්. practice කරලා අදාගන්න හරි ලේසි. You have to think of the මම කියලා දුන්නේ you have to think of the atomic number, electronic configuration, then the number of valence electrons. කීයක් share කරන්න ඕනද කියලා decide කරලා ඇඳා. right? ඔයාලට අපි ඇන්දේ දැන් 10ක් නේ දැන්දේ. ඒ ටිකෙන් එළියෙන් අහන්නෙත් නෑ ගොඩක් වෙලාවට. right? So you can practice. නිකන් කටපාඩම් කරන්න එපා. Get the understanding, right? In science වල ඔයගොල්ලෝ theory එක ඉගෙන ගන්න ඊට පස්සේ දෙන කතන්දරයට theory එක apply කරා. හරි last topic ඊට පස්සේ පුංචි වීඩියෝ එකක් පෙන්නලා අපි යනවා ඊළඟ lesson එකට. හරි. Properties of ionic and covalent compounds. I think here we are going to show the ability to conduct electricity by ionic and covalent compounds. හරිද? So you are asked to take 4 beakers, 2 carbon rods, 2 bulbs, 2 batteries, then conducting wires, salt solution, sugar solution, copper sulfate solution and distilled water. So you have to immerse the 2 carbon rods in each liquid given. මේකත් grade 9 වල electrolysis lesson එකේ කතා කළා නේද? Here we are going to find out what is an electrolyte. Right? If it conducts electricity, we can conclude that. Salt solution, what type of bonds are there? Salt solution. What are the bonds? Ionic or covalent?
Ionic.
Ionic. Salt solution, ionic. Hari. Ilangata sugar solution. Sugar. Sucrose. Yes, there are covalent bonds. Copper sulfate solution. CuSO4. Another.
Ionic.
Ionic. Copper ions and sulfate ions. Sulfate radical. Distilled water. Distilled water. There are no salts or minerals dissolved in it. Therefore, distilled water is also having covalent bonds. I think water molecule එකේ covalent bonds නේ. එතකොට what would be the observation? Here the circuit gets completed through this liquid. If the liquid conducts electricity, the bulb will glow. If the liquid does not conduct electricity, the bulb will not glow. Right? What are the electrolytes here? Observation. The bulb glows when? Yes. Then these are used as the electrolyte. Oh, another.
Salt solution and copper sulfate.
Salt solution and copper sulfate
sulfate
solution. Aliana, the bulb glows when salt solution and copper sulfate solution are used. Bulb glows when the salt solution and copper sulfate solution are used. මෙතන අපි එකම carbon rods දෙකනේ use කරන්නේ. Here it says the carbon rods should be washed well before using the other solution. Before we immerse it in the next solution, we have to wash them with water because the droplets of the previous liquid can be remained on the electrode. And therefore, we have to clean them. Hari. Then you have to say the bulb does not glow when sugar solution and distilled water are used. And so what is the conclusion? A salt solution and copper sulfate solution contain ionic bonds. ඊට පස්සේ sugar solution and distilled water contain covalent bonds. එතකොට liquids or solutions with ionic bonds conduct electricity. Liquids or solutions with covalent bonds do not conduct electricity. පුලන්නේ තනින් ලියන්න. So you have to say these two have ionic bonds, these two have covalent bonds. So liquids or solutions with ionic bonds conduct electricity. තනින් ලියන්න දැන් අසාලිවිම ලියන්න ඕනේ නෑනේ grade 10 වලදී නේද? මේකටම අපි acidified water ගත්තා නම් මොකද වෙන්නේ? It is also acidified water. Will it conduct or not?
It will conduct.
Conduct. හරි. ලිව්වා නේද? Then we will mention, till you are given, you don't need to write, the characteristics of ionic compounds and covalent compounds. Hari. Ionic compounds are composed of oppositely charged ions. Now we have mentioned that several times, right? Oppositely charged ions.
Excuse me, teacher.
Yes.
Teacher, I had a connection issue. Did you tell about the conclusion?
Yes, I asked the others to write the conclusion alone. So I mentioned salt solution and copper sulfate solution have ionic bonds, contain ionic bonds. Then sugar solution and distilled water have covalent bonds. Liquids or solutions with ionic bonds conduct electricity. Liquids or solutions with covalent bonds do not conduct electricity. That's what I asked them to write alone, Pahani.
Okay, teacher, thank you.
Hari. Most of the compounds have a solid crystalline form at room temperature. Then ionic compounds, most of them make ionic lattices, solid crystalline. They have, because of that, they have high melting points and boiling points. The melting points and boiling points are comparatively high in the case of ionic compounds. They conduct electricity in the fused or molten state and aqueous solutions. Ionic compounds, the grade 9 the solid ionic compounds do not conduct electricity since they don't have mobile ions. Harida. Ionic compounds in solid state. Ionic compounds in solid state do not conduct electricity since they don't have mobile ions. Don't have mobile ions. The movable ions are not there. But they conduct electricity in the fused or molten state and aqueous solution. Right? Fused or molten can solid is heated and taken into the liquid state. Right? Melt. Fused state නැත්නම් molten state කියන්නේ මෙහෙම. ඊළඟට aqueous කියලා කියන්නේ dissolve in water. Aqueous. Dissolve in water, right? Dissolve in water. Dissolve in water. For example, as the fused or molten state එකට අපිට කියන්න පුළුවන් sodium chloride liquid කියලා රත් කරලා liquefy කරනවා. NaCl L කියන්නේ liquid. ඊට පස්සේ aqueous solution කියන්නේ sodium chloride dissolved in water. Then we write it as NaCl AQ. Aqueous. Aqua කියන්නේ water නේ. එතකොට AQ කියලා දානවා within brackets. Hari. Then most of the ionic compounds are soluble in water. Most of them are soluble in water. Hari. Then what about covalent compounds? They mostly exist as molecules composed of several atoms. Most of the atoms, ions atoms. Most of the covalent compounds are in the liquid or gaseous state at room temperature, but there are certain molecules in the solid state as well. Generally, the melting points and boiling points of ionic compounds are low, but there are exceptions. The ones who make lattices like diamond, graphite, they have the lattice compounds. Lattice compounds have high boiling points and melting points like diamond, graphite. Covalent unata, since they make a lattice, atomic lattice, they have high boiling points and melting points generally. The aqueous solutions of covalent compounds do not conduct electricity. Some of the covalent compounds are soluble in water, like glucose, sugar. Though they have covalent bonds, they are soluble in water. Some of them are soluble. හරි නේද? දැන් මහන්සිත් ඇතිනේ. ගොඩක් වෙලා කතා කළා, ගොඩක් වෙලා කිව්වා නේද? හරි. I will share a video, and after that I will give a little break and we are moving on to the 11th lesson. DNA වල අහනවා intermolecular bonds ද කියලා. hydrogen bonds තමයි තියෙන්නේ in DNA molecule in between the nitrogenous bases of one polynucleotide chain and the other polynucleotide chain. There are hydrogen bonds. ප්‍රශ්න මතක් වෙනවා නේද? හරි.
Let's take a look at the intermolecular forces for H. This is water. When we look at intermolecular forces, the first thing we need to ask, are there any ions present? Since we don't have a negative or a positive up here, there aren't any ions present, and we can just forget about this part here of our flow chart. The next question we need to ask, are there polar molecules present? So is water a polar molecule? If we take a look at the Lewis structure for water, we can see we have the water molecule, 2 hydrogen atoms, and then these 2 lone pairs here. We really need to look at the molecular geometry to get a better sense. So here's our water molecule, and those 2 lone pairs up here, they force these hydrogen atoms down. So we have a side where we have the oxygen, which is more electronegative, and then the hydrogens. So this side of the molecule here on top, this is going to be a little more negative, and then on the bottom, this will be a little more positive. So water is a polar molecule, so we do have a polar molecule present. If you need help figuring out why water is polar, there's a link in the description at the end of this video as well. So we have a polar molecule. Water is a polar molecule. The next question is, are these hydrogen atoms bonded to either fluorine, oxygen, or nitrogen? And here's our oxygen atom. So yes, the hydrogens are bonded to an oxygen atom. That means we have hydrogen bonding. So for water, hydrogen bonding, that's going to be the primary intermolecular force. We'll also have dipole-dipole forces and London dispersion forces as well. But it's that hydrogen bonding that's really the main intermolecular force when we talk about H2O, water. And it does explain a lot of the chemical and physical properties of water as well. This is Dr. B looking at the intermolecular forces for water, H2O. Hydrogen bonding is the main one, but we do have dipole-dipole and London dispersion forces as well.
Welcome to Tadashi Science, where our goal
This is your brain.
Minds. Ready to unlock the secrets of our amazing world? Let's get started. Have you ever wondered how tiny, invisible atoms stick together to build everything in the universe, including you? The secret is that most atoms feel happy or stable when they have a full outer shell of electrons. Atoms have two main ways to get a full shell and become stable. They can either give and take electrons, or they can share them. Meet sodium. It has one extra electron in its outer shell that it would love to give away to feel more stable. And here's chlorine. It has 7 outer electrons and just needs one more to have a perfect set of 8. So, sodium gives its extra electron to chlorine. Now, both atoms have achieved their goal of having a full outer shell. When an atom gives or takes an electron, it's called an ionic bond. The two atoms become oppositely charged and stick together. You see ionic bonds in everyday table salt. It's made of sodium and chlorine atoms held together by this powerful attraction. But what if atoms don't want to give away electrons? Meet oxygen. It needs 2 more electrons, but it prefers to share. So, it shares with 2 hydrogen atoms. Each hydrogen shares its 1 electron, and the oxygen shares 1 back with each of them. This sharing creates a strong connection called a covalent bond. The atoms are now locked together as a team or a molecule. You see covalent bonds in water. That's 1 oxygen and 2 hydrogen atoms sharing electrons to form the amazing water molecule. These chemical bonds are like the glue of the universe. They hold atoms together to create everything from sugar to plastic. From the water in our streams to the air we breathe, everything is made of molecules held together by these amazing bonds. So remember, chemical bonds are how atoms team up by giving, taking, or sharing electrons to build our incredible world. If you like this video, like, share, and subscribe.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about the difference between ionic and covalent bonding, and also how you can tell them apart from their formula. Ionic bonds are formed from metals and nonmetals. or a metal and a polyatomic ion, which are typically made of nonmetals. Covalent bonds are formed from two or more nonmetals. If you look at the periodic table, you can locate this stair step. Elements to the left of the stair step are metals, except for hydrogen, which is a nonmetal, and to the right are nonmetals. So you can look at the chemical formula and see if you have a combination of metals and nonmetals. Let's look at some examples of ionic bonds. Sodium chloride, NaCl. It's made of sodium, which is a metal, and chlorine, which is a nonmetal. Potassium bromide. It's made of potassium, which is a metal, and bromine, which is a nonmetal. What about this compound? It has more than two elements, like the previous examples. Lithium nitrate. It's made of lithium, which is a metal, and two nonmetals bonded together called nitrate, which is a polyatomic ion, which are elements bonded together but act as one. I deal with these types of ionic bonds in another video. But again, it's a metal and nonmetal bonding together, so it's an ionic bond. Now, what about sulfur dioxide? It's made of sulfur and oxygen, which are both nonmetal, so it's a covalent bond. What about H2O? They are connected because they are sharing electrons, and this holds the compound together. So, how are the atoms held together in these different compounds? Let's look at covalent bonds first. Compounds with covalent bonds are held together because they are sharing electrons. Let's take a look at water. They are connected because they are sharing electrons, and this holds the compound together. Now let's look at sodium chloride, which is held together by an ionic bond. Chlorine wants one electron, so it takes one electron from sodium. As a result, sodium and chlorine become ions, which is an element with a positive or negative charge. The sodium becomes a positively charged ion called a cation, and chlorine becomes a negatively charged ion called an anion. Now you have a negative and positive charge attracted to one another, and this bonds the element together. So how can you remember the difference? With a covalent bond, I think of co-presidents, which share the power, or you cohabitate with someone, so you share a space. And with ionic, I think, I want your electron, which results in an ion. Thanks for watching, and remember, kindness multiplies kindness. Be kind to someone today.
Okay, you can have a little break and come back. I'm going to continue for another 1 hour after the break, right? You can drink some water and come back. We are moving on to the 11th unit, right?